Hi, Matt Allington here, and this is a follow-up video to the video I did earlier in the week where I talked about the case fatality rate of COVID-19 here in Australia. Now, unfortunately, I actually made a mistake in the video earlier in the week. I was referring to the infection fatality rate instead of the case fatality rate. So let me just talk about the difference. So the case fatality rate is defined by the total deaths from a disease, in this case COVID, divided by the total recorded cases, and that's of course what's called the case fatality rate. The infection fatality rate is normally lower than the case fatality rate because the total infections that exist in a community are not always measured, and therefore it's normal that the total infections are higher than the total recorded cases, and as a result of that the infection fatality rate is often lower, sometimes much lower than the official case fatality rates. In fact, I've heard numbers quoted of between 2 and 10 times lower infection fatality rate than case fatality rate. But putting that aside, the point that I wanted to make here is that in the video that you're about to see, I incorrectly referred to the infection fatality rate. And so, as I hope you can appreciate, it takes a lot of work to produce one of these videos. I already recorded the video with the infection fatality rate reference in there, and so I've put a few bubbles in there just to highlight the fact that they're different, but I haven't gone back and re-recorded the video. This video today is all about the process of actually producing this report rather than the actual data, and therefore I trust that you will run with me on that and keep in mind that I'm actually talking about the case fatality rate. I'm going to do something a little bit different today. Now, quite often I get asked by students and people on forums, they say to me, what can I do to get practice using Power BI so that I can get some real world experience? And one of the things that I recommend that you do is pick a topic that you care about, that you're passionate about, and then go and find some real world data and then use that data and do some analysis. Practice your data modeling skills, practice your Power Query skills, load the data up and then see what you can find out from that data. And that's exactly what I'm going to do today, because I'm a bit frustrated by the lack of information available in the Australian media around topics that I care about with COVID. So specifically, I want to know what is the infection fatality rate of COVID for the latest wave of COVID outbreaks here in Australia. So if you're not from Australia, you may or may not know that we're currently experiencing a wave of COVID infections, but it appears to me, at least on the surface, that the fatality rate of this recent wave of COVID is lower than previous waves. And so with that in mind, I set about finding some data and I couldn't find the information that I was after, and therefore I decided to try and build something myself so that I could analyze the data myself and understand, is this true, is this not true? And I'm going to go through that process now. I'm going to show you what I did to build the final report that I've already produced. So I'm going to go through the process again, and then I'll show you how I built up on the concepts and built the tool to be able to help myself answer the questions. And spoiler alert, the jury's out still, whether it is or it isn't. I still suspect that the infection fatality rate is lower, but I'll show you what I'm talking about when we get into the data. So let me start off by talking about the data that I'm using. I've sourced my data from this website. It's an excellent website, and the easiest way to find it is just to go to ourworldindata.org, and once you get here you can click on one of these COVID links and it pretty much takes you to the same location. And once I get in here, I just click on Data Explorer and that takes you to the page that I showed you when I first navigated here. So this is a pretty comprehensive website. It has lots of inbuilt capabilities, but it doesn't have the ability to create calculations that are using the data. So infection fatality rate is the deaths divided by the number of confirmed cases. But fortunately, you can come down here and click this download link, and that's exactly what I did, and I downloaded the coronavirus data. Okay, so obviously the first thing to do is to load the data. So I need to get data. It happens to be a CSV, and so I'll go into the file, make a connection to the file, and here's a sample of the data. I'll go straight into transform. And here is the CSV. Now this is in its raw form. It's not the best way to load the data. And so the first thing I'm going to do is right click and turn off the load so that I have a permanent connection to that CSV file. The next thing I'm going to do is start to build a star schema. So those of you that follow me will know that this is an important part of building any data model. And so I need to understand what's the best way to structure the data. And so I can see here I have this continent and location and ISO code. So when I first did this, this occurred to me that this was by country, but I wasn't clear the number of countries and what the level of granularity is. So does this ISO code map to this location, for example? And what I actually did, and I probably could use Power Query, but just so that I can take you through the process that I went through, I decided just to go ahead and load that data. In fact, I need to come back and I will actually just load this table and do that again. And so what I decided to do is just load the data up, and that gives me an opportunity of doing some quick inspections of the data to understand what's going on. And so if I jump over here and I come to this ISO code column, you'll see down the bottom that there's 231 distinct values. The continent has 7, so there's a one-to-many relationship there. And this location has got 231. So the same number of locations as there are ISO codes. And so therefore it's clear to me that the ISO code is the key for the location. And then I have this single date column, and then pretty much everything else appears to be some sort of data. So it was just a quick way for me to do a quick visual inspection of that data. So I'm then going to go back and I will turn this back so that it doesn't load, and I'll set about, first of all, building my country table. So I'll right click and reference this query, and so this will be country. Maybe could be call it location, it doesn't really matter. So I need to keep these 3 columns and remove the other columns. And once I've done that, I need to remove duplicates. Note that I've got all 3 selected. In this case, it wouldn't matter. If I just selected the ISO code, I already know that there's a 1-to-1 relationship between ISO code and location. So just right click and remove duplicates. And this should give me 231 rows, which are all the unique countries in this particular data set. Now, if you just have a look at these codes, this is something that I discovered later, but I may as well fix it now. Notice that some of these continents actually have a blank here. And so it occurs to me that this is probably summary level data that's embedded inside the data set, which is rolled up by continent. But of course, we don't need that. We can do that in Power BI. So I could come here and just filter out the blanks, and that would get rid of them. But maybe what I'll do is I'll come over here and I'll see if I can filter out the continent here. Now, before I do that, I'm actually going to put a filter on blanks because I want to see what are the blanks. And so this can pretty much confirms what I thought before, and that is that when there's no continent, this must be some sort of summary level data. And so I don't need that, and I'm just going to change this filter from being equals to be not equal. And so I've actually now filtered the source data so that it only contains the data that relates to one of the individual countries. And that of course flows through here to the country table that I've already created. Okay, so now we've got the country. I need to basically load the rest of the data. And so I can now remove these 2 columns because they're stored in my dimension table. So I'll right click and remove them. In fact, what I need to do first is reference that. So this is going to be my data. And in here, I'm going to remove these 2 columns, just keeping the primary key, which is the ISO code. I'll keep the date. I'll need to create a calendar table in a moment for that. And then it appears that everything else here is some sort of data. And so I'm going to unpivot that. So select these 2 columns, right click, unpivot other columns. And in this case, pretty much that attribute is exactly what I need. The attribute is the name of the data, and then this value column is the data that I've got loaded. So now you can see that the data set here is currently set as ABC123, which means it's not clear. It's basically, that's data type any. And I do want to show you a problem that I came across because I changed this to decimal number. But if I now put a filter here and say keep errors, you'll see that there's actually an error that's been triggered. And if I come down here, you'll see that there's some text that appears in this column. And I wasn't clear what that was, but with a little bit of investigating, I discovered that when the attribute is test units, the information that is in this column is actually giving me information about how the testing was done. And so rather than deal with that problem, I actually didn't care so much about the test units. And so what I decided to do was to come down here and basically exclude anything that was related to the test units. So after I put a filter on tests units, then if I come over here and change this to a decimal number and do keep rows, keep errors, that will go ahead and load all of the data. It'll check for errors. And as you can see, there are no longer any errors. So that solved that particular problem. So now I have the data table, I have the country table. I should produce a calendar table. My preferred method of creating a calendar table is to jump over to OneNote, and I've actually got a copy of this calendar table just off screen. I'll copy that and I'll come here and do a new query, a blank query, switch to the advanced editor, and I'll paste the code. And this is the code that I keep in OneNote. It just makes the process of building a calendar table so much easier. I rarely vary from this particular calendar table. I do have a blog article about this, which we'll put a link in the blog and also the video. Okay, so here's my calendar table, and the way this one works is that you just specify the start date. And in this case, I started the data in 2020, and the end date auto calculates as being the end of the current year. And that's good practice when you're building a calendar table. And so I need to call this calendar. And now I've got the three tables I can close and apply. And I'll switch over here to the model view. Interesting, two of those columns automatically joined, but this one didn't. And so I've manually joined the calendar table to the data date. And now I can start to build out a visual to start to have a look at the data. And this is exactly what I did when I was actually going through this exercise. And so I brought the attribute in. So these are all the different measures that are available in that data set. And if you just bring in the raw number, it doesn't mean anything at this point in time, but it does give you an opportunity to start to do an ocular evaluation of the data. So just to eyeball the data to see what's going on. And so here's an interesting piece of data, which is the new cases and also new deaths. So these are the two pieces of information that I wanted. And in the case of my demo, what I did first of all was to write my first measure. And so this will be new cases. And that is equal to calculate sum of the value. But I need to, of course, put a filter on the data attribute is equal to whatever it is in the attribute column. In this case, it's new underscore cases. So I'm going to bring that into a new visual so that I can have a look at it. And I'll change that to a table and I'll bring the country location in. And so now I can see the total new cases by country. In fact, because I'm doing this analysis just for Australia, I'm now going to come over here, put a filter on all pages, and that will be country is Australia. And this just means that I don't have to filter the data if I want to change it down the track. And now I've got the new cases. So just to help with the visualization, maybe I'll remove the location and bring the date in. And that's automatically giving me something to look at. In fact, what I might do is I'll bring in my year and month column. So I need to set that one so that it doesn't summarize. And now we can see the cases. So notice how what I'm doing is I'm loading the data, I'm doing some sort of eyeballing of the data to try and understand the data. Then what I'm doing is writing my first measure and then sticking it immediately inside a visual so that I can start to have a look at it and make sure it's performing as I expect. This is always the way I build new models with my customers and anything else that I'm doing. Okay, so now I've got the new cases. I need to know about deaths. And so in this case, new deaths is going to follow this exact pattern. And so I could just copy that measure and I'll do a new measure. And this will be new deaths. Maybe the word new doesn't make a lot of sense here, but it's I'll leave it there. And so this is going to be called, I'll bring it into the visual and I'll make sure I do some formatting before I move on. So I'll make these whole numbers with a comma, and same with the new cases, whole number. Okay, so there we have a bit of data. That's the raw data that we need to be able to understand the case fatality rate. But of course, these numbers are on any given month. And in order to do some analysis, what I really have to understand is which deaths are related to which cases. Of course, there were 18 deaths in the month. This is March 2020. And there are 4,500 cases, but sometimes the timing between these things are different. And so the next thing that I really wanted to do was to start to visualize the data a little bit better. So I'm going to create a chart and I'm going to bring my two measures into this chart. In fact, what I really want to do is I'm going to put cases as a line and I'll bring the date onto the shared axis, and I want this to be the physical date. All right, so now I'm actually starting to get a visual exploration of the data, and I can actually see now that the timing of the cases precedes the deaths, and in fact one of the issues with this chart is the zeros aren't aligned. So that's the next thing to fix, is come up to the y-axis. And I'll set the axis to start at 0. The other thing is that this chart is a little bit hard to see because the line is so dark. So what I'll do is I'll come over here under data colors. The cases needs to be lighter, so I'll make that a light blue, and I'll change this one to a darker blue, so just so that the deaths sort of show out from behind. And in fact, this line is very fat, so I need to come to shapes, and I'll just change the stroke width so that it's a lot finer, and that just makes it a lot easier to see the data. And so once again, I'm taking you on a journey here to show you how I went about building the final report, which I'll go through shortly. So you can see here that there was a lot of activity. This was the issue in Melbourne last year, which was widely reported on the news. But you can definitely see here that there's fatality rates trail the infection rate, and I'll show you how I went about analysing that. Okay, but my objective was I wanted to understand, is the infection fatality rate less for the current outbreak than it was for the previous outbreaks? And so one of the issues is, how do you align the infections against the deaths in order to make sure that you're doing some appropriate analysis? And it's going to be somewhat arbitrary, I guess, but by having this visual here, what I was able to do was to make an assessment that there were a number of different phases. And I went about setting up my own phasing, and I'll show you that phasing. So I'll just open my phase here, and this is what I decided to use as my phasing. So starting from 1st of January 20 through to the 31st of May. Now, how did I come up with these dates? Well, frankly, all I did was I had a look here and I tried to find some natural breakpoints. And in fact, if I take a duplicate of this and I'll turn this into a matrix, sometimes just having a look at the actual data itself can make that process a little bit easier. So charts help you understand at what point you need to care, but obviously looking at the data can also be useful. So something was sort of happening around here, 7th of June. And in fact, there's lots of zeros here. So I actually came across this problem when I was working on this. And so I'm going to come up and I'm going to get rid of those zeros, because the zeros, of course, force the date to display even if there's nothing relevant to see. So I'll just go back to edit query, And what I'll do while I'm here, I'll get rid of these nulls, and I'll also get rid of the zeros. So that just lightens the data load, and it means that the visuals will hide these dates where there was no relevant activity, and that just makes it easier to do the analysis and exploration. Okay, so as I said, this seems to be, in my opinion, the first phase, or the first wave, if you want to call it that. And so somewhere around the 5th of June. And so if I come in here, you can see that here's May, and as we come up towards the end of June. And so I pretty much, if you're looking at these deaths here, it seems to have pretty much either slowed down or stopped at this point in time. And so I took you call it an arbitrary decision if you like, but I took a decision to say my first phase for analysis would be through to the 31st of May. My second phase would start on the 1st of June and would come through to some data point. And as you can see here, using this eyeballing approach, I decided to take it through to the end of October, then the next phase through to the end of May, and then the latest activity started to occur sort of in the first couple of weeks of June. And so they're the phases that I decided to use. So in order to do the analysis, I need to get those phases into the model so that I can start to use those phases inside my analysis. And so back to Power Query. And the next thing to do is to load that data. And so here is my phase data that I've set up. And so this is the data. I don't need to load this data. I just need to have it available. What I do need to do is I need to join this data. I need this information in my calendar table. I need a new column in my calendar table that tells me for every date in the calendar table, which phase does that date belong to. Now, when I first looked at this, I thought, oh, that's a tricky little problem because I can't just join these two columns to my calendar table. And so the way I decided to solve this problem was to turn this table into a list of every single date. And so to do that, I need to enumerate a list of all the dates from the 1st of the 1st through to the 31st of the 5th, making sure that that keeps the phase 1 column. And so I'm going to have a problem here. So the first thing I might do is just replace this null, and I want to replace it with today's date. So I'm going to come up, transform, replace values. Now I actually don't know the syntax for today's date, so I'm going to find the null and replace it with 1. And I can't use 1, looks like I have to use a date. So I'm just picking any arbitrary date. And by doing that, the code gets generated automatically for me. You can see that I've hard-coded the date in here. And now I can use the IntelliSense to help me with the code that I need. And so I need today's date. And I happen to know that that's something along the lines of local now. So there it is, date time, local now. And I need to do an open and close brackets. And so just let's check that. And that's correct, that's the date, but this is date time, and I've done this before, so I'm going to use date time dot date, and I need to close the brackets here. All right, so now I've got my end date, and of course next time I refresh this, that end date will continue to expand. In fact, if I use this to expand it, then my phase 4 is going to leave nulls in my calendar table from the 20th of July through to the end of the year. I think that's okay. All right, so now that I've got a start date and an end date, I can use this list.dates function to create a list of all the dates in this period. So I'll add column, custom column, and this will be my list of dates. I'll just leave it called custom. And so the function is called list.dates. It wants to know the start date. Well, that's the start date there. And it wants to know, unfortunately, not the end date. It wants to know how many dates are required. Now, I've done this before, so I'll just show you how you do it. You need to take the end date and you need to subtract the start date. But unfortunately, it doesn't end there. And that's because this will give you some sort of date time data type, and we actually need to know the number of integers or how many days in that period. And so once again, from experience, there's a function called duration.days, and if I use that function, that will actually extract the integers, how many days in that period. And in fact, I have to add 1 to it because it'll be 1 short based on subtracting the start date and end date. And then lastly, it's asking me what's the step of, so as we increment, what are we stepping? Is it seconds, hours, days, whatever? And it's going to be days. And to do that, it's hash duration. And then I say 1, 0, all right, and then close brackets. So I'm pretty sure that's it. Let's go and have a look. And this creates a list. And if I click on the list down here, you'll see it starts on the 1st of the 1st. But let's go ahead and expand this list, expand to new rows, and we'll just do a quick check. So 1st to the 31st. So if I come down here to the 31st, and then we start the new period 1st through to, so that'll, yeah, 1st to the 6th. Okay, so now I can get rid of these, and now I have a list of all the dates, and I need to change this probably to a date. So for every date, it tells me what phase it is, and then with that, I can come up to my calendar table, and I'll do a merge queries, and I'll merge the date with my phases, and join on the custom, and then I can extract the phase into my calendar table. And so now I've basically got the 4 phases plus the nulls, which are any dates that go through to the end of the year because they may or may not be part of that phase. Okay, so I've got my phase data loaded. So let's bring that in. Bring it in as a new table. You can see I've got those blanks. I know those blanks exist. And so in this case, I think I will just simply get rid of those blanks. So I might put a filter on this page, and I'll do an advanced filter. It's important I do an advanced filter here and not manually select these phases and deselect that one, because as new phases come in, that would become a problem. So I'll do an advanced filter, does not or is not blank, and hit apply. So that gets rid of the blank phases, which are all basically future dates. And let me just bring in my 2 measures, new cases and new deaths. And so now I've got my cases and deaths for each of those phases as I had identified them. And I can set about now doing my infection fatality rate. And so this will just be a new measure. And this will be, I'll just call it IFR is equal to divide the new deaths by the new cases. As I said, maybe the word new doesn't make a lot of sense, but that'll do. And if I put that in, I'll need to change that to a percentage and 2 decimal places. And there you can see the various infection fatality rates for the different periods. Okay, so with that in mind, there's a whole lot of other things that I can do. But as I started to look at this data, even though the initial results seem to suggest that phase 4 is a much lower infection fatality rate, notice that as we went into this phase 2, you'll notice that the infection rate did start to go up quite a lot prior to the death rate actually starting to go up. So then it occurred to me, well, I really need to know how many days into the phase am I so that I can make that assessment. And so I need to write a measure that tells me how many days am I into each of the phases. And so to do that, I'll write another measure. I'll put this one in the calendar table. And I'll just go ahead and write this from scratch again. So I'll call this days into phase. And so the first thing I need to know is which phase am I in. So I'll do a variable, and I'll call it this phase. And this phase is going to be equal to the max of the phase. Interesting fact is that you can use the max function in DAX over text columns. That's perfectly allowable. It'll just use the alpha sorted version of that column to work out which one is the max. And so if I just want to test that, I can just go return this phase. This is one of my power tips. Always test your measures as you're going along to make sure that they're doing what you expect them to do. So now I know what the phase is. I can set about counting how many days are we into this phase. And so if I was to pick any particular date here, I would want to know, say if we take this date here, in fact, let me bring this in to show you. So back here, this is phase 1. How many days in am I at the 5th of January? Well, of course, it would be all of the days up to and including the 5th. And so that's what I need to do. So I need to write a filter. And so I'll do another variable, today date is equal to, let's just do max of the date. So that should be fine. And then I can do var result. So I need to calculate count rows of the calendar table. But before I do that, I need to filter all the calendar table. And I only want to keep the current phase. So its calendar phase is equal to this phase. And in addition, I only want to keep the dates up to and including the current date. And I can see I've made an error there. So let me go back and fix that. And so up to and including the current date, which is max date. And so basically I need calendar date is less than or equal to today's date. So let's check that out. And if I expand this a little bit, you can see now that this goes up and up and up, and I think it was the end of May. And so at the end of the May, we're 152 days into that phase, and then it resets again. So that measure appears to be working as I need it. And so what I'm going to do with that measure is I'm going to add it as a tooltip. I can use it to help me understand what's going on. And so admittedly, this is somewhat of an arbitrary starting point. Now using that tooltip, if I hover over one of these data points, you'll see that about day 44, the deaths started to step up a little bit. And if I come over here, we can see that we're already in day 47. So I would say based on this data, it's a little bit too early to tell. But I think definitely in the next couple of weeks, if we don't see an escalation of the death rates, then it would be fair to call out the fact that the infection fatality rate is much lower than it was in previous phases. So with that, I'm going to jump back to the final version, the one that I did originally, and just show you the information that I've built. So I'll bring that onto the screen. So yeah, this is the one that I built prior to doing the demo that I've just showed you. I've got the data down here so that I can actually see exactly what's going on. And I've built some visualization. So I've included a start date for the phase. And let me show you that. So the start date is just simply the minimum of the calendar date. I've wrapped it with a has one value because I didn't want the start date to appear here. Because this is a measure, this will return 1st of January 2020 if I don't wrap this inside a has one value. So that's that one. If I come over here, so the total days for each of the phases, remember that this was somewhat arbitrary based on the way I did an ocular evaluation of the data. You can see the total number of new cases that have occurred during that period, and then the deaths. I've calculated the infection fatality rate, and then I went ahead and did a calculation how much less fatal is each of these phases compared with the worst phase. And so I worked out that this is the worst phase, phase 2, therefore that's equally fatal, 1.0, but phase 3 was 33 times less fatal. Phase 4 was, so far, 17.6 times less fatal, but let's wait and see what happens as the data continues to come in. I will show you that formula, times less fatal. And so this measure, I first of all worked out what is the worst result for any of the phases. I did that by using a maxx. So a maxx is an iterating function. It steps through all of the phases. So it steps through all 4 current phases. And for each phase, it works out what is the infection fatality rate, and it keeps the biggest one. That's what the max part of maxx does. So that tells me what's the worst rate. This part of the formula tells me what the rate is for this particular phase, and then I divide those 2 numbers by each other to work out the number of times less fatal the current phase is versus the worst phase that we have data for. Of course, I can come up here, I can slice and dice and see the actual data. So here's the data for phase 3, for phase 4. Phase 2, of course, was the worst one by far. Okay, so that's it. I thought you might find the process that I go through in building such reports interesting. I tried to reproduce what I actually did through the process as faithfully as I could, and to show you some of the problems that I came across. And yeah, hopefully this will inspire you to perhaps do your own investigation on this data, to dig out some insights that you're not able to get from the various sources. And I'm going to post this book with my blog article, so go to my website if you'd like to download this workbook. Of course, you'll need to download the data yourself if you want to do any enhancements on that or continue to use that data in the future.